Imagine standing on a multi-billion-dollar offshore oil rig.
Oh, just a massive, massive structure.
Right. You are surrounded by, thousands of tons of steel just braving the ocean. You've
Yep.
got these towering distillation columns and miles of thick, high-pressure piping.
Pulling up massive profits from beneath the Earth's crust.
Exactly. It feels like this colossal, unstoppable feat of macro engineering.
It really does.
But now, imagine that entire towering behemoth just grinding to a dead, sickening halt, losing millions of dollars a day, and all because of a tiny, invisible miscalculation, like the size of a teardrop.
Yeah, and it happens way more often than most facility managers would ever like to admit.
Really?
Oh, absolutely. I mean, we get so blinded by the sheer scale of the infrastructure, right?
Yeah.
We completely forget that the entire system is held together by absolute microscopic precision.
Down at the chemical level.
Down at the chemical level, exactly.
Well, that structural vulnerability is exactly our mission for this deep dive. Today, we are zooming all the way in.
Getting down into the weeds.
We are. We're exploring the highly specific, zero margin for error world of industrial chemical injection.
A fascinating topic, honestly.
It is. Specifically, we are looking at the absolute workhorse of the field, which is the Texsteam Series 2400 electric pump, and the critical supply logistics network of PE Energy that keeps these mechanisms running.
Because without them, the whole thing falls apart.
Right. We are going to uncover how pinprep mechanical precision impacts everything from, massive corporate return on investment to actual on-the-ground human safety.
Because stripping away the theory to look at the hard reality of these operations, it reveals a pretty stark picture.
How so?
Well, in heavy industry, a sloppy pump is not just some minor maintenance quirk. It's a direct, immediate threat to facility uptime, operating budgets, and, frankly, the physical safety of the personnel on site.
Wow. Okay, so I have our stack of sources right here, pulling from technical specifications, maintenance data, and some highly strategic procurement models for these high-performance chemical pumps.
Great data in there, yeah.
But before we can understand how these machines save companies literally millions of dollars, we have to understand the anatomy of that precision, right?
We need to know what they do and how they actually function mechanically under extreme stress.
Exactly. Because the mechanics dictate the economics.
They do. In an environment as unforgiving as an oil field, you simply cannot separate the two.
Okay, let's unpack this. Because the term they use in the sources is positive displacement, right?
Positive displacement pump.
So, to understand positive displacement, imagine a medical syringe. When you pull the plunger back, the barrel fills with an exact fixed volume of liquid.
A very specific, measurable amount.
Yeah. And when you push it down, that exact volume is forced out. It doesn't matter if you're pushing that fluid into an empty cup or like a highly pressurized balloon.
The volume delivered is mathematically absolute.
Mathematically absolute. So the Texsteam 2400 pump is basically doing that, but acting as an industrial IV drip for a multi-billion-dollar patient.
I love that analogy, yeah. Its entire job is delivering precise amounts of highly specialized treatment chemicals right into the flow lines.
And those chemicals are doing heavy lifting. Right.
Oh, huge heavy lifting. You have corrosion inhibitors, which literally form a microscopic protective film on the inside of the steel pipe.
So the harsh well fluids don't just eat straight through the metal.
Exactly. And then you have scale inhibitors. Those prevent calcium carbonate and other minerals from building up.
Right. The sources mentioned that buildup can literally choke a 10-inch pipe down to a 2-inch pipe.
It's like clogged arteries. And then there is demulsification, which chemically breaks the emulsion of crude oil and water drawn from the reservoir.
So it can actually be processed.
Yeah. So if that IV drip pushes too much medication or too little,
the facility's vital signs crash.
They absolutely crash.
Now, for anyone listening who has worked with standard fluid transfer, you know that with a centrifugal pump, you're always fighting the curve.
Oh, the hydraulic curve, yeah.
Right. If the line pressure spikes, your flow rate wanders because the spinning impeller just can't push as much fluid against that sudden resistance.
The flow fluctuates wildly based on whatever the pipe is doing at that exact second.
But the Texsteam is different.
Very. What's fascinating here is exactly how the Texsteam 2400 removes that curve entirely. It relies on the positive displacement mechanism you just visualized with the syringe.
So how does it actually do that mechanically?
Well, the electric motor drives a gear reducer, and that turns rotational motion into linear thrust.
Okay.
And that thrust pushes a plunger of a highly specific size, mind you, into a fluid chamber.
Meaning it essentially ignores the pressure pushing back against it.
Completely ignores it.
It physically traps the liquid and just overpowers the line pressure, forcing the chemical action.
It has to overpower it. The variables in an oil field are, they're extreme and constantly shifting.
I can imagine.
You have different flow ranges required for different wellheads, different skids, fluctuating environmental conditions.
Right, so the pressure isn't always the same.
Never. But whether the 2400 is injecting into a low-pressure manifold or pushing against its absolute maximum discharge pressure, it delivers the exact same predictable volume.
Wow.
It isolates the chemical delivery from all the hydraulic chaos happening inside the pipeline.
Which is huge, because if the machine doesn't wander, the injection numbers don't wander.
Exactly.
And that raw mechanical accuracy triggers massive, measurable ripple effects on the business side of the operation. It's like it is the physical bridge between the engineering department and the finance department.
I like to say predictable physics creates predictable accounting.
Right. Well, here's where it gets really interesting. Looking at the performance data in our sources, something jumped out at me that seems almost, I don't know, petty at first glance.
Petty? How so?
Well, these operations managers are celebrating moving their facility uptime from 97% to 98.5%.
Ah, I see what you mean.
Right. To an outsider, fighting over 1.5% seems like splitting hairs. Like, wait, if you're an operations director, why are you measuring uptime in mere percentage points?
It sounds tiny.
Is a slight variance in chemical delivery really a threat to the bottom line when you are already running 97% of the time?
It seems like splitting hairs until you do the math on the sheer volume of production we're talking about here.
Break that down for us.
Okay, if we connect this to the bigger picture, a modern offshore rig might be producing, say, 100,000 barrels of oil a day.
Okay.
At $80 a barrel, that is $8 million of gross revenue daily.
8 million. Every single day.
Every single day. So a single percentage point of downtime doesn't mean a few $1,000s. It means tens of thousands of dollars lost per day.
Wow.
Millions over a quarter. And that's not to mention idle labor and deferred production.
Right, the crew's still getting paid even if the rig isn't pumping.
Exactly. So when we talk about a slight variance in chemical delivery throwing off that uptime, we're looking at two very expensive scenarios: overfeeds and underfeeds.
Let's start with overfeeds. If the pump is sloppy and overfeeds, I have to imagine you were just spraying incredibly expensive, highly engineered polymers into the pipe for absolutely no reason.
Hit the nail on the head. You are basically burning budget without gaining any extra chemical benefit whatsoever.
Just literally flushing money down the pipeline.
Yep. Over the course of a year, across dozens of wellheads, injecting just 5% more chemical than the engineering spec requires.
Yeah.
That will entirely consume your operating margin.
That is insane.
These are proprietary chemicals, often shipped to incredibly remote locations.
Right, getting them there isn't cheap either.
Not at all. Wasting them is a massive logistical and financial failure.
Yet, reading through the failure analyses in our sources, an underfeed actually seems significantly more dangerous to the operation.
Oh, an underfeed is where you lose those precious percentage points of uptime we just talked about.
Because the chemical isn't there to do its job.
Right. If the pump wanders and delivers too little chemical, the scale inhibition fails.
And the minerals start calcifying inside the valves.
Exactly. The corrosion control breaks down, and the hydrogen sulfide in the well fluid begins actively corroding the steel.
Which has to lead to a disaster eventually.
It does eventually. That leads to a catastrophic equipment failure, a high-pressure line bursts, a critical valve seizes.
And the entire facility has to trigger an emergency shutdown to contain the damage.
And there goes your $8 million a day.
Man. Well, the sources gave us a crucial, hard data point on how to actually solve this.
The standardization case study?
Yes. When an operations director took a mixed, mismatched fleet of varying chemical injectors, some wandering, some failing, and standardized the entire site to these Texsteam positive displacement pumps, they didn't just see a marginal improvement.
No, it was significant.
They cut their chemical variance by double digits.
Which is massive. Which means for the first time, their actual chemical consumption numbers finally matched their quarterly budgets and their key performance indicators.
No more guessing where the budget went.
Right. The finance team isn't looking at wild, unpredictable expense reports trying to figure out where the corrosion inhibitor went this month.
Because standardizing the mechanical injection standardized the financial reporting.
It brought everything into alignment.
And obviously, if you were running an operations budget, that kind of predictability is your primary goal.
Absolutely.
But this discussion goes far beyond just protecting the bottom line. We have to look at the human element here, too.
Yes, the safety aspect is arguably even more important.
Because highly accurate machinery fundamentally changes the day-to-day lives of the mechanics, the technicians, and the operators who are actually out there turning wrenches on the facility.
Leaving the ivory tower financial theory behind for a minute, the real-world maintenance trade-offs that actually matter to reliability teams, they all come down to one metric.
Which is?
Human exposure.
Right. Reading the maintenance data, these teams are hyper-focused on specific components. They're tracking the lifespan of the packing seals, the electric motors, and the gear reducers inside the pump.
They care about the gears, stepping down that fast motor speed into a slow, powerful stroke.
And they care about the seals holding back the fluids.
Because every time a seal blows or a motor burns out, a human being has to physically go fix it.
And that's not just a walk in the park?
No. Think about the physical environment where these pumps are installed. They are frequently located in hazardous zones.
The sources mentioned the ambient environment might contain highly pressurized hydrocarbons.
Or deadly H2S gas.
Hydrogen sulfide, which, for those who aren't familiar, is incredibly toxic, highly corrosive, and can be lethal even in parts per million.
It is genuinely one of the most dangerous occupational hazards in the industry.
So every single time a sloppy pump fails, clogs, or wanders out of calibration,
An operator has to physically walk into that hazardous zone, put their hands on the equipment, and manually intervene.
So wait, how exactly does the internal design of a pump prevent an audit nightmare for a safety officer? Because it stands to reason, then, that utilizing precision metering basically solves this.
It does. Deploying a pump like the 2400 that holds its calibration without constant babysitting drastically reduces the need for those operator interventions.
Because fewer mechanical failures naturally mean fewer humans walking into a danger zone.
Exactly. Safety auditors track how often personnel are exposed to hazardous situations.
Right.
If your equipment operates reliably without requiring constant manual adjustments, your overall exposure rates plummet.
Which completely cures the audit headaches that keep safety officers awake at night.
Because the overall risk profile of the entire facility drops.
That makes total sense.
Yeah.
And the sources also dig heavily into MTTR, right? Mean time to repair.
Yes, MTTR. Because even the best equipment needs servicing eventually.
Of course. But there's a massive difference between scheduled maintenance and an emergency blowout.
Night and day, predictable maintenance is safe maintenance.
How does the tech team help with that?
Well, when the 2400 does need scheduled servicing, say, replacing a seal after a known number of operating hours, its modular design leads to a highly predictable mean time to repair.
So no guessing games.
None. The reliability team knows exactly how long the job will take, they can isolate the energy sources safely, and they can perform the work without the chaos of an unplanned shutdown.
Because emergency repairs under pressure are exactly where fatal mistakes happen.
That's when people get hurt.
Okay, so we've established that predictable maintenance is safe maintenance, and it protects the facility's massive revenue stream.
Right.
But predictable assumes you actually have the parts to do the repair.
Yes. The logistics.
If this highly engineered pump blows a seal at 2 in the morning and you don't have a replacement, all that safety and ROI math goes entirely out the window.
It does. The hardware is only as robust as the logistics network backing it up.
Because buying industrial equipment requires navigating a really complex global supply chain.
Very complex.
So what does this all mean? Let me give you an analogy.
Okay, let's hear it.
Owning a fleet of these high-performance Texsteam pumps without a supply partner like PE Energy is kind of like buying a state-of-the-art billion-dollar server farm, but forgetting to wire it to the power grid.
That's a great way to look at it.
Right. Like, the hardware itself might be flawless,
Yeah.
but without the ecosystem feeding it the necessary inputs, it is just a highly engineered paperweight.
Exactly. Because industrial supply is fundamentally different from commercial retail.
How so?
Well, commodity sellers will take your purchase order, ship a crate to your loading dock, and consider the transaction complete.
Wash their hands of it.
Yep. If a gear reducer fails 6 months later, you are on your own to track down the manufacturer and beg for an expedited shipping date.
Which could take weeks.
Or months. But a true industrial partner operates on a completely different model.
The sources really emphasize how a partner like PE Energy integrates into the facility's actual operations.
Right, they aren't just handing over a catalog. They are providing guaranteed inventory.
And they utilize predictive analytics, right? Based on the wear and tear of your specific fleet.
Yes, to ensure critical parts are available before the rig even knows it needs them.
That's wild.
They might hold consignment stock locally, Or provide factory-trained technical support that actually understands the hydraulic nuances of your specific wellhead.
Because when things go sideways at 2 a.m., you cannot afford to wait 6 weeks for a proprietary seal to clear customs.
No, you're losing millions, remember? Having a partner with certified repair parts ready to deploy is what keeps that 98.5% uptime intact.
If you are a procurement manager listening to this, you already know the headache of chasing warranties across 6 different manufacturers.
Oh, it's a nightmare.
It is a massive job to manage multiple sites. And standardizing the fleet through a consolidated procurement strategy with one partner doesn't just save money.
It saves your sanity.
Literally saves your sanity.
This raises an important question for those procurement managers, though.
Which is,
How do you strategically navigate standard versus custom equipment?
oh, interesting.
A sophisticated partner helps you analyze the engineering requirements to decide when it makes financial sense to buy standard off-the-shelf pump configurations.
To lock in price stability and lead times.
Right. And when the application strictly demands a custom-engineered package to handle unique pressures or highly corrosive fluids.
So you're not just guessing. The buyer's checklist from the procurement data is essentially a roadmap for avoiding future crises.
It really is.
Before the purchase order even hits the printer, the procurement team must validate the mechanical specs, ensuring the plunger sizes and flow ranges perfectly match the hydraulic realities of the site.
They must validate the warranty terms, too.
And they absolutely must confirm that on-site 24/7 technical support is structurally part of the contract.
Because the initial purchase price of a chemical injection pump is just a fraction of its total life cycle cost.
Right.
If you fail to validate the logistics, the spare parts availability, and the support network beforehand,
What happens?
you are simply pre-ordering a catastrophic failure for your operations team down the line.
Wow. Well, that interconnectedness brings us full circle on this entire deep dive today.
It really connects all the dots.
We started by looking at the microscopic mechanics, how the physical plunger sizes and that brilliant positive displacement design ignore line pressure.
Stops the pump from wandering.
Right, and keeps the chemical IV drip mathematically perfect.
And then we followed that mechanical precision up the chain to see how it directly translates to business ROI.
Eliminating those double-digit chemical variances stops facilities from spraying pure profit into the pipeline.
And preventing underfeeds protects those critical percentage points of uptime that translate to millions and millions of dollars.
Then we look at the human reality on the deck plates, seeing how that same reliability drastically reduces hazardous interventions.
Because keeping operators out of H2S environments keeps safety officers sane.
And ensures that maintenance is scheduled, predictable, and safe.
And finally, we zoomed all the way out to the macro level, the vital supply chain logistics.
Right, how partnerships with organizations like PE Energy provide the predictive inventory, the standardization strategies, and the 2 a.m. support.
Which is absolutely necessary to keep the entire mechanical ecosystem alive.
From a tiny packing seal holding back corrosive fluid inside a single pump, all the way up to the global logistics network moving parts across the world.
It's incredible when you step back and look at it.
It really makes you look at those massive, towering offshore rigs entirely differently. The giants are truly at the mercy of the micro-mechanisms.
In any complex, high-stakes system, the small details are the only things that actually matter.
Absolutely. So, to everyone listening, I want to leave you with a final thought to ponder today.
Think about your own industry, your own business, or even your daily routines.
Consider the hidden pumps in your world. What is that seemingly small, unglamorous mechanism, process, or logistical partner that you rely on entirely without ever looking at it?
Because if that invisible mechanism suddenly started to wander out of calibration,
would it throw your entire system off budget? Or completely out of compliance? Take a close look around your own operations. You might just find your own Texsteam 2400 hiding in plain sight.